Our next speaker is Professor Adam Voelkel from the University in Poznan, Poland. And actually, when you screen the literature about inverse gas chromatography or IGC, there's no way you can miss him and his group. Altogether, there are around 100 papers published on this subject, and it's therefore our special pleasure to have him as our second speaker. His title is How to Apply Inverse Gas Chromatography in Our Research. And with this, I welcome you on this virtual symposium. Yes.
Okay, I'm a member of a Poznan group working on IGC, using IGC for, I don't know, many years, say 20, 25 years. And we decided to show several examples, three exact examples of our activity. The first one is devoted to abrasive materials. Abrasive materials are combined manufacture with alloxide as hard particles, and these are connected with the use of different resins. A manufacturer observed that after storage of final product, its properties are worse. Activity decreases, and we were asked to solve, to find the reason of such behavior. You can see okay, I will check. Okay, last. You can see the photo of the new resin, and after 3 weeks of storage, and it's different material, even without any changes, any examination by chemical techniques. Resin is two types of resins are applied in the manufacturing. Abrasive materials is a mixture, most often mixture. Resin is a thermosetting material, and it's cross-linked with the use of elevated temperature. The second resin is Novolac. Here we have typical chemical process, and the setting material is urotropin, which enables the formation of proper structure. We used several techniques to check the changes occurring in the storage of material. Of course, we applied also inverse gas chromatography. We used free energy of the surface to express the activity of material, and it is very common. This equation allows to calculate dispersive component of surface free energy, but using polar test solutes, test compounds, it is possible to determine the specific component of absorption energy, and from these values, using chloroform and ethylamine as a test solutes, it is possible to determine components of the surface energy corresponding to acidic and basic interactions, exactly electron donor and electron acceptor interactions. Besides IGC, we used also FTIR, near infrared, pyrolysis gas chromatography with mass spectra detection, and other several techniques. The IGC was found to be the most unstable, the most sensitive technique. And you can see the changes occurring and during the storage of material for the mixture of two resins, here for resin and here for Novolac. And as you can see, the changes of the respective parameters for Novolac are much higher, and we suggested the manufacturer that Novolac, the quality of this resin is responsible for the stability of final product, abrasive materials. These results were published in Journal of Chromatography, and it was several years ago. And manufacturer was satisfied with these results, and thanks to these results, he changed slightly technology and composition of the resin mixture. Another part of our activity is our solubility parameter, and solubility parameters determined by IGC. And for all people who are not familiar with a theory, solubility parameter was introduced 100 years ago by Hildebrand. You have here definition, but this definition has some limitations, and more than 50 years ago, Hansen, Danish scientist and engineer, introduced so-called Hansen solubility parameter, where the cohesive energy is considered as a sum of contribution from dispersive polar and hydrogen bonding components. 2 or 3 years ago, we celebrated 50 years of this applicability of Hansen solubility parameters in York. Steve Abbott organized such very nice, very interesting meeting, and today's chairman, Ralph Dimpelman, also attended this event. And solubility parameter may be applied in many tasks to solve many problems, both in pharmaceutical industry or in analytical examination of, say, activity of adsorbents, and so we use in the different types. By IGC, a solubility parameter in this, as defined by Hildebrand, was calculated by Smith-Rodriguez 50 years ago. And from very simple relation, you have here equation describing the straight line, and from the slope of the straight line, it is possible to calculate solubility parameter of examined material polymer. It works quite well for high molecular weight polymers, but for the smaller particles, there are several problems. So we, following Price from England, we propose to calculate the components of solubility parameter corresponding to dispersive polar and hydrogen bonding interactions. This parameter, this component, describe the ability of material to act as through dispersive interactions, polar or hydrogen bonding. Although here there are many problems with selection of solvents, because when you like to use the data from literature, you can find very strange information. Yes, for example, for acetonitrile, from one source, you obtain such relation, such value, from the other also different, and there are problem, and wrong selection may lead to erroneous results. So in cooperation with people from Leverkusen, Rainer Bellinghausen, we proposed the procedure to calculate components of Hansen solubility parameters. It's one equation. Here is the interaction parameter obtained from IGC measurements, experiments, and these values for series of test solutes might be used to calculate the component. It works very, very nice, and you can see these values are little different from these previous ones, where we have to select test solutes. In this case of ABV method procedure, there is no need to select test solute, no place for error. And you can see all these results were published in Journal of Chromatography with Rainer Bellinghausen and other colleagues. All these equations, including this previous one, are valid for examination of polymers, where we assume there's a bulk sorption in the material above TG. If we have a real solid, these equations shouldn't be applied. And very often I found in the newspapers and paper journals strange publications where these equations, the previous equations, were used for solids. For solids, it's possible to calculate Hansen solubility parameters using old, very old model proposed by Snyder and Harger. I think it was 1970s, something like this. And here adsorption energy is related to solubility parameters of the interacting media, so test solutes and examined materials. In such a way, we determined Hansen solubility parameters for ibuprofen, and here you can see the comparison of results of our calculations with additive method. You know, error